So let me talk about the two questions in Mock 4. For question 2a, Paul has prepared 5 questions in descriptive statistics, 10 questions in probability, and 12 questions in probability distributions. From these prepared questions, 9 will be selected randomly for the quiz of statistics that will be held next week. So we need to calculate the probability that the quiz will consist of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distributions. From the given information, we know that the total number of questions prepared is 27. If we want to find the probability, first, we need to find the number of ways to fulfill the requirement. That is 5C2 times 10C4 times 12C3. 5C2 means that choosing 2 questions from the 5 prepared questions in descriptive statistics and the remaining is the same. Since they are independent events, we apply the multiplication rule. The answer is 462,000. Hence, the required probability is 462,000 over 27C9. 27C9 is the number of ways to select 9 questions randomly. And the final answer is 560 over 5,681. For question 2b, a survey is conducted to study the customer behavior of a convenience store. It is found that 70% of the customers patronize the convenience store every day. 56% of the customers purchase newspapers. For those customers who patronize the convenience store every day, 75% purchase newspapers. We let A be the event that the customers patronize the convenience store every day, and B be the event that the customers purchase newspapers. Given that the probability of A is 0.7, the probability of B is 0.56, and the probability of B given A is 0.75. For question number 1, we need to calculate the probability that a randomly selected customer neither patronizes the convenience store every day nor purchases newspapers. For this question, we can use the complementary rule. That is 1 minus the probability of the union of event A and B, so that we can exclude all the probability of event A and B. For further calculation, we can apply the addition rule and the multiplication rule for dependent events. The steps are listed below. The final answer is 0.265. For question 2, given that a customer purchases newspapers, what is the probability that this customer patronizes the convenience store every day? This is a question related to conditional probability. That is the probability of the intersection of A and B, which means a customer purchased newspaper and patronized the convenience store, over the probability of event B, which is the probability of a customer purchases newspapers. The steps are listed below. And the final answer is 0.9375. For question 3, given that a customer does not patronize the convenience store every day, we need to calculate the probability that this customer purchases newspapers. We can apply the complementary rule again to calculate the probability that a customer does not patronize the convenience store every day. That is 1 minus 0.7, that is 0.3. Next, we need to find out the probability of the intersection of the event that a customer does not patronize the convenience store every day and event B. To calculate this, we can use the probability of event B to minus the probability of the intersection of event A and B. The answer is 0.035. To calculate the probability that a customer purchases newspapers given that a customer does not patronize the convenience store every day, we can apply the conditional probability again. That is the probability of the intersection of the event that a customer does not patronize the convenience store every day and event B over the probability of event that a customer does not patronize the convenience store every day. That is 0.035 over 0.3. The answer is 7 over 60 and the steps are listed below.
I will illustrate two questions in Mod 1. For question 2b, it is given that the probabilities of Mr. Chen, Mr. Lee, and Mr. Zheng will be elected are 0.3, 0.5, and 0.2 respectively, and the probabilities for an increase in membership fees given that Mr. Chen, Mr. Lee, and Mr. Zheng was elected are 0.8, 0.1, and 0.4 respectively. In this question, we are required to find the probability of Mr. Zheng was elected given that the fee is increased. According to the formula, probability of B given A equals to the probability of the intersection of A and B divided by the probability of A. From the formula, we can find that the probability of the intersection of A and B equals to the probability of A times probability of B given A, and as well as equals to the probability of B times the probability of A given B. Hence, the probability of the intersection of Mr. Zheng will be elected and the fees will be increased equals to the probability of Mr. Zheng will be elected times the probability for an increase in fees given Mr. Zheng was elected, which equals to 0.2 times 0.4 and therefore equals to 0.08. And for the probability of A, it equals to the probability of B1 times the probability of A given B1 plus the probability of B2 times the probability of A given B2 plus etc. and finally plus the probability of Bx times the probability of A given Bx. By this, we can find that the probability for an increase in fee equals to the probability of Mr. Chen will be elected times the probability for an increase in fee given Mr. Chen was elected plus the probability of Mr. Lee will be elected times the probability for an increase in fee given Mr. Lee was elected plus the probability of Mr. Zheng will be elected times the probability for an increase in fee given Mr. Zheng was elected, which equals to 0.3 times 0.8 plus 0.5 times 0.1 plus 0.2 times 0.4 and finally equals to 0.37. Therefore, we can find the probability of Mr. Zheng will be elected given the fee is increased by dividing the probability for an increase in fee over the probability of the intersection of Mr. Zheng will be elected and the fee is increased, which equals to 0.08 divided by 0.37. And finally, we can find that the required probability is 0.2162. For question 2c, 8 pairs of twin brothers participate in a forum. We need to find the probability that there is exactly one matching pair of twin brothers among the 6, if 6 of them are selected at random to form a group for further discussion. We can find this probability by using 2c1 to the power 4 times xc1 times 7c4, then divided by 16c6. Then we can find the answer. The required probability is 0.559.
That is the end of our presentation. Thank you.